Hey guys, John here. I just want to make a quick video showing just how easy it is to set up one of these small Tesla drive units for a custom EV conversion. So I just have the minimum components required to get it running in your car. Not necessarily the minimum components I'd recommend for a completed vehicle, but it's just the minimum setup to get things started. So I'll just list the components, and then when I start hooking them up, I'll describe their use. So of course you have your small Tesla drive unit, 250 horsepower. You got your inverter. You have the positive and negative connections of the inverter. You're going to need a high voltage battery, of course. In this case, I just have a 110 volt battery for testing here in my apartment. Negative and positive connections of the battery. You have your main contactor, pre-charge resistor, pre-charge relay, your on-off, forward reverse, and your start buttons. And you might have another button for, say, neutral or something like that. Add 12 volt battery. I just have a 12 volt power supply that I'm using for testing. And of course, you're going to need a wiring harness to hook everything up. I just whipped this up for this video. And if you buy one of these units from me, I will help you make one of these wiring harnesses, as well as include some of these basic components you need. So let's hook it up. So let's start with the low voltage side. Let's hook up the inverter. Our 12 volt battery. This supplies power to the inverter. Electronics. Let's hook up our on-off switch, and this actually disconnects the 12 volts going to the inverter. Our forward reverse. And our start button. Got a throttle. I'm just using a little cheap Chinese motorcycle style throttle for testing. You can use any Hall effect type throttle or even a potentiometer throttle. Most OEM throttles will work just fine. They just need a quick calibration in the software. Come on. All right, so let's hook up our high voltage. So let's do the main contactor first. The purpose of the main contactor is to control access of the high voltage battery to the inverter. So basically it's a disconnect for the high voltage. Polarity does matter on these contactors. In this case, this is the positive side. So we'll hook that to the positive of the battery. And we have a visitor. Come on, bud. This is Booger. He's coming to inspect the arrangement. He's a good boy, except when he goes on the laptop. And the other side goes to the inverter. So as you can see, it just gives direct connection from the battery to the inverter when the contactor is closed. So positive battery, contactor, positive of the inverter. And of course, the main contactor is controlled by the inverter via the wiring harness. Now we have our pre-charge and our pre-charge relay. So I like to hook up positive side of the battery directly to the pre-charge resistor, and then to the pre-charge relay. And then the other side of the relay goes to the same place on the inverter. Come on now. There we go. Positive side of the inverter. And again, the pre-charge relay is also controlled by the inverter. What else do we need? And the negative of the inverter goes directly to the negative of the battery. And I think that's everything. And it should just run. That's it. I mean, it only took me, what, 1 minute to hook everything up for testing. So let's turn it on. You should hear, when I turn it on, you should hear the, this is the on button. You should hear the pre-charge relay immediately pre-charge. There we go. So now it's pre-charged. So basically it took positive the battery through the resistor, which limited the current, charged the positive side of the inverter's capacitors. And when we hit the start button, it should close, assuming it is pre-charged, it should close the main contactor. And there we go. And it opened the pre-charge relay because it's not necessary to keep this closed. And now it should be in neutral. This is what I'm using for my forward. It's just a forward button. You'd have a separate button for a reverse switch. So currently it's in neutral, so the throttle should not do anything. Right. Let's put it in forward. And that's it. I have it set for a really low current. As you can see, it's nice and smooth. The control unit for the inverter is made by Johannes Hubner. It's the Open Inverter project. The PCB for interfacing with the Tesla unit was designed by Damien McGuire. I soldered them up myself, but you can actually purchase them directly from Open Inverter. So there is a Wi-Fi board on the inverter. And so to connect to it, once it's configured, it will connect directly to your router, or it will set up its own access point. In this case, I have it connected to my router, and so it should come up immediately. And this is it here. Basically, you can update the inverter firmware. And you can go through this is where you do the tuning of the inverter. There are a lot of parameters, and it can be a little bit daunting, but the reality is 95% of these will be set and forget when we first get your conversion running. And you're only going to need maybe 5 or 6 of these for tuning the performance of the inverter. And that's going to be your boost, your field weakening, your slip frequencies, min and max, and then you're going to tune your maximum currents and whatnot. And the rest of these are just going to be set and forget, and I'll help you with all this type of stuff. So right now I have it set for, let's see, derating. I have it set for 120 amps. Let's turn that up to 250 amps. There we go. Let's try it now. There we go. Let's get that going again. As you can see, even only on 110 volts, it's still nice and smooth, very peppy. So it spins up and spins down quickly because I have regenerative braking. Basically, it's a Tesla style throttle. So once you release the throttle, it will regen. So if I disable regen, because it's an induction motor, it will spin for a very long time. So I'm going to disable regen with that. I'll show you what happens. It has such low losses and low friction, it'll spin for a really long time if you don't have regen on. That's probably about 8,000 RPM right there. Maybe 10,000. Let's turn regen back on. So I think that's it. Like I said, I have a few of these units for sale. If you buy one of these, this is a front drive unit. The only difference between the front and rear drive units is the mounting arrangement. The performance is exactly the same. And I have front and rear units available for sale. And if you buy one of the units from me, I'll include some of these basic components like your pre-charge resistor, pre-charge relay, pre-charge contactor, and I'll help you make a wiring harness for your vehicle. Anyway, any questions, hit me up. Appreciate it. Take care, guys.